All right, greetings everyone. I hope this message finds you all well, or this video finds you all well. In this particular video, I am going to provide a review and supplement for Module 4B, which is talking about knowledge representation. And in this particular video, we are going to talk about approaches to categorization. All right, so let's go ahead and get started talking about concepts and categories. All right, so your textbook starts out with kind of a hypothetical situation where you find yourself in a town that you have never been to before. So you imagine that you are in an unfamiliar town where you've never been, and as you walk down the street, you start to notice many things that are not exactly the same as what you were typically used to, right? So for example, maybe if you grew up in Atlanta, which is also a very busy, bustling town, but you go to Savannah, right? So Savannah has a lot of really unique architectural features with its sort of grid-like structure. So maybe that would strike you as unusual if you've never been to Savannah before. But there's going to be a lot of other things that seem familiar, right? So for example, you see cars that are passing by, maybe people walking on the sidewalk, maybe on bicycles or on segways. There are buildings on either side of the street, and there are things like parking meters and gas stations, right, which we've all encountered in Atlanta before. So even with these sort of unusual features, like the grid-like structure and the trees with the Spanish moss, right? You'll recognize some of the other features that are common across large cities in Georgia. So kind of what this illustrates is the fact that you know what's going on when you see parking meters and cars and gas stations and bicycles, because your mind is full of what are called concepts. So a concept is just a mental representation that's used for a variety of cognitive functions, including memory, reasoning, and especially in the case of language. So a concept is going to aid in that understanding, right? Because it allows you to, drawing on concepts, right, is going to include information about different things, right? So for example, we all have a concept of a cat, right? So if we label something as a cat, we know that this particular animal, it has 4 legs, it has a tail, it has pointy ears, and so on, right? So by far the most commonly studied function of concepts is the idea of categorization, or the act of categorization, which is simply the process of putting concepts into groups called categories, right? So for example, when you see a cat, you could categorize it as a Siamese cat, a calico cat, a Persian cat, or what have you. Just like if you saw a vehicle on the street, you could categorize it as an SUV, a Chevrolet, a Ford, etc. Right? Okay, so a concept is just a mental representation that we use for a variety of cognitive functions to benefit our understanding, and categorization is just the process of placing concepts into groups based on characteristic features, and we call those groups categories. Okay, so here's some examples of common categorization. We can categorize objects in our physical world, right? So we can categorize different kinds of furniture into tables and chairs. We can talk about dogs and cats, trees, etc. We can also categorize types of people, perhaps based on their profession, so policemen, teachers, students, etc. We can categorize them based on our prior experience with them and what we deem their personality to be or their behavior to be. So for example, if we've had a lot of negative interactions, we might label someone as our enemy, whereas if we've had a lot of positive interactions, we might label them as our friend. If we have had a lot of conversations with people and they tend to sort of go on and on, we might say they were talkative or annoying or what have you. And we can also categorize based on ethnicity, race, religion, things like that. So those are fairly concrete categories or examples of categories, but there's also fairly abstract categories, right? So for example, the idea of moral concepts like crime or theft or complaining, right? All of those things are categorized as crimes when they feature very different qualities to them, right? And we also have categories like relative, right? That can feature many different kinds of relationships, mothers, fathers, sisters, brothers, aunts, uncles, etc. And credit is another great example of an abstract category. It's much less consistent, right? We can talk about credit as being a credit card, right? Or we can talk about credit in the form of a loan or the form of some kind of collateral, right? So there's a lot of disparity in those particular kinds of categories that are much less sort of concrete. Okay, we can also talk about what categories allow us to do, right? Or the kinds of reasoning or cognition that we can do once we've placed a concept into a category, right? So for example, if you see a dog, you can categorize it as an object, right? And place it into a category. So for example, you could say that dog is a member of the category dog. That dog is an exemplar in the category collie, etc. So you can do sort of global category of mammal all the way down to a more specific category of collie. You can also draw an inference from a categorization to other properties of the object, right? So if a friend tells you, I have a collie, you might think to yourself, I hope she doesn't mind dog hair on her clothes because they're dogs that shed a lot, right? So you're inferring something about her experience with that dog based on your knowledge of that particular category of dogs, right? And you can even draw an inference based on a single property of a category to a possible property of another category, right? So if a friend tells you that fluorescent lights can damage a CD, right? Not that many of us use those anymore, but it can. So if you hold a compact disc under a fluorescent light, particularly one that contains data, you might very well lose that data as a result of damage to the disk. So you might wonder, based on your knowledge of the category of compact discs, whether that would generalize to a similar property of another category, which is DVDs, right? So whether you can infer that that property of getting wrecked under the lights would transfer to a very similar category of DVDs. Okay, so one of the other most important functions of categories is that they are what's called pointers of knowledge. So one of the most important functions of categories is that they help us understand individual cases we have never seen before, right? So for example, being able to say that a random furry animal is a cat, right, is going to provide you with a great deal of information about it, right? So for example, if you see something that's been categorized as a cat, you know that it loves to catch mice, it likes to eat milk and fish, It's a feline, which means it's related to lions and tigers. It meows and purrs, etc. So right away, that category membership is going to tell you a lot about this particular cat, even though you've never seen this cat before. Okay, so next what we're going to talk about is the particular theories that have been posited as far as how we come to categorize different concepts. So perhaps the simplest approach to categorization is the definitional approach, right? And that just says that we decide if something is a member of a particular category or not by determining if that object meets the definition of a category, right? So this definitional approach would work very, very well for things like geometric shapes, right? So for example, if we were trying to decide if something is a square, right? A square is defined as a plane figure that has 4 equal sides, right? So if those characteristic features are not present in the object, if it has 3 sides instead of 4 sides, we know that it's not, we can't categorize it as a square. But for a lot of other more complex categories, such as birds, trees, plants, and even a lot of man-made objects like chairs, this kind of strict definitional approach doesn't really work. So let's talk about what some of the limitations to this particular approach of categorization are with respect to these more complex objects. Okay, so again, according to the definitional approach, category membership is basically determined simply by checking off a list of necessary features, right? So for example, we might define something as a teacup if it's a concrete object, if it's concave or it has a hole in it, if it holds liquids, if it has a handle, and if it can be used to drink hot liquids, right? But right away we can see that there probably are some exceptions to this rule, right? So if we think about our requirements 4 and 5, the requirement that it has to have a handle, right? Well, not all teacups have handles, right? So for example, Chinese teacups don't have handles. And not all teacups can be used to drink hot liquids, right? What about a teacup made of lacquer, right? Which is used more for a decorative purpose, right? So right away we see that our definition might not be appropriate, right? Because it excludes some things that we would consider teacups, right? And if we take those features away, so if we say, okay, our definition of a teacup is going to be the features 1 through 3 here, concrete object, concave, and can hold liquids, right? Just those features by themselves could include other objects, like things like bowls, for example, right? So even for something as simple as a teacup, we find that this definition falls short. Okay, so I gave you before the example of a chair. So why is it that we can't categorize chairs using this definitional approach? Well, the problem is that not all members of everyday categories like chairs have the same features, right? So, for example, if we looked on Webster.com, the definition of a chair is a piece of furniture consisting of a seat, legs, back, and often arms designed to accommodate one person. Right? So that sounds like, at first blush, maybe a reasonable definition of what a chair is, but there are objects which we would refer to as chairs that don't necessarily meet that definition. Right? So for example, in the picture there, we have kind of a disc-like piece of furniture, which we certainly can sit in, even though it doesn't have arms or a back to speak of. And the same thing for the rock there, right? If you were on a hike or something like that outside and you chose to have a seat on a rock, it would be functioning as a chair, right? So here we see that a definition of a chair, as we've defined it, doesn't really encapsulate all of the possibilities for things that we would categorize as a chair. Okay, so how do we reconcile this? So how do we come up with a theory of categorization that recovers from some of the shortcomings of the definitional approach? Well, a researcher by the name of Wittgenstein proposed a different idea. So he proposed what's called the categorization approach of family resemblance. Okay? So with family resemblance, it's just the notion that things in a particular category resemble one another in a number of ways, right? And this is the criteria, right? So instead of saying that there's a definite criteria that every member of a category must meet, the family resemblance approach simply says that there can be some variation within the category, right? Their chairs may come in many different sizes and shapes and be made of all kinds of different materials, but every chair does resemble other chairs in some way, right? So they have some things in common in that they offer a place to sit, a way to support someone's back, and perhaps a place to rest your arms, right? So there are things that are different among these exemplars of the category chair, but they do have overlapping features, right? Okay, so one of the classic examples that Wittgenstein uses is in the following quote. So consider for example, the proceedings we call games. I mean board games, card games, ball games, Olympic games, and so on. For if you were to look at them, you will not see something in common to all, but similarities, relationships, and a whole series of them at that. I can think of no better expression to categorize these similarities than family resemblances, right? So in the case of games, it's very, very difficult to come up with a feature that encapsulates all of the different types of games there are. But a lot of times there's overlapping features, right? Like oftentimes when you play a game, there's a particular set of rules that you are bound to follow, and so on. Right? So we don't have to, when we're categorizing concepts, not all of the members of the category have to meet a set of definitive principles, but rather they just have to have features across the category that are in common. Right. So again, Wittgenstein proposed that members of a category have a family resemblance to each other. Right, so we look at this particular family based upon their kind of superficial or physical features. We see that dark hair, glasses, a mustache, and a big nose are typical of this family, but they do not define the family, right? So several members of this category have glasses, and several members of this family have dark hair, right? But there are some members of the category for which that is not true, right? So again, as long as there are overlapping features that most of the exemplars have in common, we would say that they all belong to the same category. Okay. So another type of, or another approach to categorization is something called the prototype approach. So according to the prototype approach to categorization, membership in a category is determined by comparing a given object to a prototype that represents the category. And in this case, a prototype is a typical member of the category. Right? So what is a typical member of the category? Well, Eleanor Roche, who is a very famous cognitive psychologist, in 1973, she proposed that the typical prototype is based on a statistical average of members of the category that are commonly experienced. So for example, for the prototype of the category birds, okay, would be based on birds that you typically see. So for example, I am from the coast of Virginia, and in Virginia we often see cardinals, and we also frequently see sparrows and robins, right? So my prototype or my statistical average is going to have a lot of the same features of those types of birds, right? So one of the things that's important to realize about the prototype approach is the prototype isn't a physical or an actual member of the category, but rather an average that your mind has created that takes into account all of the most frequent features of the various birds that you have encountered, right? So we have, if you've been exposed to 3 actual birds, a sparrow, a robin, and a blue jay, the prototype is going to be the average representation of those features in this particular category. Okay, so one of the things that is interesting is that Eleanor Roche, in her research, when she gave people a list of 50 members of a particular category and had them rate each of those category members on how typical that member is of the category, what she found is that if participants were told to rate the typicality of a particular category member on a scale from 1 to 7, where 1 means it's a very good or typical member of that category, and 7 is that it's very atypical of that category, she found that prototypical items, okay, were judged to be better examples of the category than items that were not prototypical, right? So again, the 1.18 rating for sparrow, okay, reflects the fact that most people would agree that a sparrow is a good example of a bird, right? The 4.53 rating for penguin and the 6.15 rating for bat is reflective of the fact that penguins and bats are not considered good examples of a bird, right? Similarly, if we go to the category furniture, chair and sofa have a rating of about 1.4 and are thus considered very good examples of furniture, whereas mirror and telephone have ratings of 4.39 and 6.68 respectively, so they're not as good examples, right? So one of the other things that Roche discovered is that items that are considered prototypical, so items that have a lot in common with the prototype, okay, also have many overlapping features, right? So there's a strong relationship between prototypicality and family resemblance, right? So when items have a large amount of overlap with characteristics of other items in a category, the family resemblance is going to be quite high. But when there's not a lot of overlap, there's low family resemblance, right? So you guys might have noticed that when you were doing your lab activity, right? If you look at your answers, right, you might see that there's a lot of overlapping features for example, sofa and couch, right? Because those are examples of furniture that have both high prototypicality and high family resemblance, whereas there's not a lot of overlapping features between mirror and telephone. Even though those are also members of the category furniture, there's not a lot of overlapping features, and they were rated lower in terms of whether they were good examples of the category furniture or not. Okay, so another interesting finding related to prototypicality or related to the prototype theory is that Edward Smith and coworkers used a procedure called the sentence verification task to determine how rapidly people could answer questions about an object's category. So when they used this technique, they found that participants responded faster for objects that were high in prototypicality. Okay, so for example, items like apple in the category fruit than they did for items that were low in prototypicality, like pomegranate, right? So this ability to judge highly prototypical categories more rapidly is called the typicality effect, right? And this makes sense, right? If you think about how categories are represented in the mind according to the prototypicality approach, essentially what you do is you compare a new object to the statistical average that you've computed, right? So going back to the bird example, if your prototype for a bird is based on your experience with robins, sparrows, and blue jays, right? If you see a penguin or an ostrich, right, there's not going to be a lot of similarity between your prototype and this bird, right? So it's going to take you longer, right, to determine whether it is a bird or not. Whereas if it highly resembles your prototype, right, it's going to be easier for you to make that determination. Okay. Another interesting finding is that when we ask participants to list as many objects in a category as possible, they tend to list the most prototypical members of the category first, right? Thus, for birds, sparrow would be named before penguins, right? And it goes back to the prototype theory, which again says that when you're making a categorization judgment, you compare a new object to your prototype, okay, and that determines whether you categorize the object or not. So it makes sense that categories are concepts or exemplars from your category that are closest to the prototype would come to mind first. So another result that seems to support this prototype approach to categorization is that prototypical objects are more affected by something called priming. So priming occurs whenever earlier presentation of a stimulus facilitates your response to another stimulus that usually follows closely in time. So let's talk about how this particular experiment was set up. So if you were a participant in this experiment, there were 3 different groups. So all participants in the experiment first heard the word green, okay? And that was the priming phase, is when they were exposed to the stimulus, okay? In this case, the color green. And then they were shown 2 different colors. So 2 seconds after they heard the word green, they saw a pair of colors side by side and indicated by pressing a key as quickly as possible whether the 2 colors were the same or different. So the side-by-side colors that they saw were paired in 3 different ways. In the first group at the top there, the colors were the same and they were good examples of the category, right? So for example, there we see 2 good examples of the category green. They're both kind of the bright primary colors that most people think of when they think of the color green. In the next group, the colors were the same as the prime. They were green, but they were less typical examples of the category. So they were a much lighter shade of green than what we typically think of when we think of the color green. And in the last case, the color swatches that were presented were different than the prime. So the colors were different, with the 2 colors coming from different categories. Okay? So again, the particular measurement that Eleanor Roche was interested in for this particular experiment is she was looking at how quickly participants could look at those 2 colors and decide whether they were the same or different. So basically the question is, how many milliseconds does it take for participants in either of these conditions to say, yes, that is the same color, or no, it is a different color? And so we're going to look at the 2 same conditions here. So the case where we have a more prototypical shade of green at the top and a less prototypical shade of green on the bottom. Okay, so what they found is that priming or hearing the word green first earlier in the experiment resulted in faster same judgments for the prototypical colors at the top. So for the prototypical colors of green at the top, it took participants an average of 610 milliseconds to respond and say, yes, those colors are the same, as opposed to the bottom condition where the color is less prototypical. It took an average of 780 milliseconds. Right? So what seems to be happening is that when participants heard the word green, they judged 2 patches of primary green as being the same more rapidly than 2 patches of light green. Excuse me. And Roche explains this as being due to the fact that when participants hear the word green, in their mind, they bring up the prototype. Okay? So when they hear the word green, they bring up their prototypical shade of green, which more closely matches, right, the first colors than the less typical colors down at the bottom, the lighter green. So when participants, again, they imagine their prototype for green, and because the good match for green is a better indicator of the prototype, they're able to make that judgment more rapidly than when the colors that they see fail to match the prototype or are a poor match of the prototype, as in the case of the lighter green. Right? So the principle behind priming is that the prime, in this case the color green, will facilitate participants' response to a stimulus if it contains some of the information needed to respond to the stimulus, right? So the prime is informative when the good greens are presented, or when the prototypical greens are presented at the test, but not when the less prototypical greens are presented. Okay, so these results support the idea, again, that participants create images of good prototypes in response to color names, right? So when they hear the color green in their mind, they pull up a prototype for the color green and compare that prototype to the colors that they see. And if the colors that they see match the prototype, that comparison is easier than if they don't match the prototype, or if they're a poor match to the prototype. All right, so we're going to talk about one more approach to categorization in this video, which is the exemplar approach. So like the prototype approach to categorization, the exemplar approach says that in order to categorize a concept into a category, what individuals do is they compare that new object to a standard object, right? So when you want to decide whether a four-legged furry animal is a cat, right, you start by comparing that object to your mind's sort of standard object for cats. But in this case, rather than comparing that object to a prototype, which is a single average member of that category, the standard object for the exemplar approach is just going to include many, many different examples of a category that you've encountered, right? So instead of comparing this new object to a single average cat or prototype for cat, you're going to compare that new object to all of the cats you have seen, and possibly all of the dogs you have seen as well, because in this case, your category would be furry, four-legged animal, right? So in your mind, you're going to bring up a catalog or Rolodex, if you will, of all of the category members you've ever encountered, and you're going to compare this new object to each of those examples, okay? So if a person, for example, has encountered sparrows, robins, and blue jays in the past, each of these would be an exemplar for the category birds, okay? And you would compare the new object to each of those types of birds, okay? And a lot of the same phenomena that we used the prototype approach to explain can also be explained using this exemplar approach. So for example, there's the typicality effect, right? So the typicality effect was, again, when we used the sentence verification task, and we found that reaction times are faster. Okay, so people are faster at saying a sparrow is a bird than a penguin is a bird, right? That's the typicality approach. But we can explain that pattern of results using this exemplar approach too. Okay, so for example, a sparrow is going to be similar to many of our examples of birds, Okay, so it's going to be classified faster than a penguin, which is going to be similar to very few of our previous examples of birds. Okay, so it's kind of similar to the notion of family resemblance, right? So for typical objects, or for typical birds, right, there's going to be fewer overlapping features between the new object and the examples we've stored in our minds than for less typical birds, okay, which are going to have fewer overlapping features with the examples we've stored in our minds. Okay? So again, the idea with the exemplar approach is that whenever we see a new object, we are going to pull up all of the examples of a particular category that we've encountered in the past, and we're going to compare that new object to all of our previous examples. And items are new objects that are very similar to our stored examples are going to be categorized faster than new objects that don't have a lot of overlapping features with examples that we've stored. All right, so the last thing I wanted to end on for this video, which approach is better? Well, the answer to that is that a lot of research suggests that we use both approaches, but that each approach has its own advantages in particular cases, right? So for example, the exemplar approach is best when we have atypical cases, right? So the case where we're comparing a new object to all of our previous examples is better when there's something atypical that we encounter, right? Because it's hard to come up with a prototype that incorporates features of both blue jays, robins, and sparrows and penguins and ostriches, right? It's hard to have one standard object that represents all of those features. But if we use the exemplar approach, right, we can just catalog all of the birds that we've seen, right? And we can just think to ourselves, okay, some of the birds I've seen can fly, and some of the birds I've seen can't fly, right? So when you see a new object, right, you compare it if the bird has some type of flight, right? You compare it to the flighted birds, and if it doesn't, you compare it to the non-flighted birds, right? So right away, you're able to have more nuances in your category or more information in your category than you would if you were just comparing it to a single average, right? And a related notion is that the exemplar approach offers a category that's more variable, right? So you can incorporate a lot of different features into your category that you wouldn't necessarily be able to represent if you were comparing it to a prototype. So for example, it would be difficult to represent a variable category like games if you were using a prototype, right? Because it's hard for just to have a single standard object for football, computer games, solitaire, marbles, etc., right? Because those are all highly variable exemplars. Whereas if you simply stored all of the examples of games you've ever been exposed to, okay, then you would be able to capture that highly variable category. Okay, the exemplar approach would be ideal in situations where the category is small for obvious reasons, right? So if you've encountered, maybe if you're a biologist or a botanist or an environmentalist, and you've encountered 350 different species of flower, right? Then maybe it would make sense to use the prototype approach, simply because that category is so massive, right? That it would take a lot of time for you to have to compare a new flower to all of those different types of flowers, right? So it's best when the category is small, so you're not bogged down with a bunch of different examples, right? So similarly, or sort of inversely, the prototype approach is going to be better when the category is large, and also when the category is new or unfamiliar, right? So obviously when the category is new or unfamiliar, right, you don't have a lot of exemplars because you don't have a lot of exposure. And if you don't have a lot of exemplars, right, then you're not going to be getting a lot of information. So in this case, it would be better to use a prototype or a single standard object. Okay, all right, so this concludes our discussion of different approaches of categorization, and I will pick things up in the next video talking about other aspects of categorization. Okay, so I'll see you guys in my next video.